Hello, everybody. Welcome back to Planet X News. It is September 1st, 2019. And ladies and gentlemen, today in this live stream, we're going to be talking about, naturally, Hurricane Dorian battering the Bahamas and eventually the east coast of the United States. We're also going to be talking about some space weather that is impacting the Earth. And we're going to talk about space weather and how Planet X affects this space weather, therefore affecting the Earth. I've noticed a few things over the last couple of months, but I've just wanted to collect more data. And this recent bout of space weather really caught my eye. And I have all of the detailed information here for you. I'm going to go over that. It's going to answer a lot of people's questions. We're going to talk a little bit about, once again, the Planet X 28-day orbit around our sun. Now, listen, folks, I know a lot of people, I don't know, I guess they may or may not agree with me on this orbit, but I've been researching this and putting this together for years now and collecting the data to corroborate what I am saying. I'm just not making it up. On top of all of that, all of the observational evidence, well, it all goes together. Now, just recently, I believe it was on the 27th, several days ago, we had once again another observational capture of this object coming up from below the ecliptic. And for all of you that were asking, what does the ecliptic stand for? How do you define the ecliptic? What is the ecliptic? That is basically the middle plane of our solar system. So the Earth rotates around the sun, and anything below that level, that halfway point, that would be below the ecliptic plane. If you really want a more scientific definition of it, Google it. But I know it's very, very early in the morning. I have a very, very busy day, 7 days a week, actually. So sometimes it's hard for me to get on YouTube in normal hours. But all of you that are missing the live stream, hey, YouTube offers you a playback, and you can play this live stream back and watch it. I'm going to go ahead and pull up the live chat here real quick, and we will go from there. Just give me 1 second. Get rid of that ad. Let me set this over here. I've been tracking this hurricane, since the very, very beginning. And we've had a relatively inactive hurricane season so far. But the peak of the hurricane season really starts around this time of year. Late August, September, October. And officially the hurricane season ends on November 1st. Unfortunately, this year, we may see a later hurricane season, meaning it may possibly end towards the end of November. So many things are happening with our weather, it's really hard to say. A lot of these weather events are completely unpredictable. And getting into Dorian, if you watched a lot of the weather updates on any of the news channels or the Weather Channel, a lot of their commentary was saying just that. They just did not know where this hurricane was going to go. And it even tricked me a few times. Very early on, I contacted several friends of mine that live in Miami, Dade, Broward, West Palm Beach County, and even friends of mine that are over on the west coast of South Florida, over in Naples and Tampa. I actually thought that this hurricane was going to track directly across the state of Florida, right below Lake Okeechobee, and head out into the Gulf of Mexico and then make a second landfall up around the Panhandle. And I was so confident that that was actually going to happen. I have two kids in FSU, Florida State University, and up in Tallahassee. And I called them both and I'm like, look, this is what's possibly going to happen. So you guys know the drill. You make sure that you do not wait to get out of the way, and I'll keep you informed. So they're still not kind of out of the woods yet because this hurricane has been just completely unpredictable. We're going to go over some of that information. And, folks, one thing that I'm concerned with, I'm very worried with, is all of the people in the Bahamas. I've been to Freeport, Grand Bahama Island, the main island that is going to be affected by this storm. I've been there probably 50 times. And the people are fantastic. I got to love the Bahamian people in all my business trips over there and my interaction with them for many, many years. They're just beautiful people. Freeport, Grand Bahama Island is only about 20 feet above sea level, and that highest point is at a lighthouse, an old lighthouse. And the far part of the island, the eastern part of the island facing out into the Atlantic Ocean, that is some of the lowest points on Freeport, Grand Bahama Island. And they're talking about a storm surge from 12 to 15 feet. That's the approximation. So if you do the math, you can see that almost all of Freeport, Grand Bahama Island and the Abaco Islands that stretch down across the outer eastern side of the Atlantic, and the Bahamas off of the eastern tip of Freeport. Folks, let me tell you, I've been out to all of these islands in my years of living in South Florida, and these islands, they're not that high off of the water. The elevation is not that high. So I ran a flood simulation just to see what 10 feet and 15 feet of storm surge would look like for Freeport, Grand Bahama Island. And I gotta say, it doesn't look good. It looks absolutely tragic. Tragic. There's a lot of people that live on the Freeport, Grand Bahama Island. It's a main tourist attraction. And tourism is just about 90% of everyone's income that lives in Freeport, Grand Bahama Island. So I'm very, very concerned about these folks. They have evacuated some of the people, and they brought them to the United States, to South Florida. So I'm sure they can't evacuate everyone. But when I did these flood simulations, the far eastern part of the island that faces out into the Atlantic Ocean, completely 100% underwater. And that side of the island is inhabited mainly by residents. There's a lot of neighborhoods, houses, things of that nature, small, short condominium buildings, things of that nature. So I don't know. It's going to be very, very tragic for these folks, and that hurricane is going to start affecting them today, and it's going to slow down quite a bit. And they're already looking at a possibility of 12 to 18 inches of rain. So say a prayer for these folks. There's a very, very high possibility that we may see a lot of loss of life on those islands in the Bahamas. So we will see. I've been thinking about these people all day yesterday and, again today. And, they've been through hurricanes before. But, folks, this storm surge, that is the big problem. Yes, the high winds are going to be damaging, 150-mile-an-hour winds. But a 12 to 15-foot storm surge, when your highest point on the island is only 20 feet, and that's at a lighthouse towards the western end of the island, and the rest of the island is basically 5, 6, 7, 8, 9, 10 feet above sea level. Well, there you go. You can do the math very simply, and you can see that the majority of that island is going to be underwater, and not just temporarily. It can possibly be underwater for a complete 24 to 36 hours. So I'll be watching that very, very carefully, and I hope and pray that nobody dies over there, but the possibilities of what is about to happen, yeah, it's been on my mind. I feel very, very bad for these people. And, over my 20-year span living in South Florida and doing a lot of business in the Bahamas, like I said, I got to know a lot of people over there, and I've been over there probably 50 times to Freeport, and it's very, very sad. They are going to be very, very devastated, and it is going to crush their economy. But we will see what happens. And as far as what's going to happen in the United States on the East Coast, hey, folks, we just have to wait and see what happens. It doesn't look too good for the eastern coastline of the state of Florida, and also moving up into the central part of Florida and Georgia, South Carolina, North Carolina, and maybe even Virginia. It's very, very hard to say what this storm is going to do. But I believe it's definitely going to bring some huge tidal surges into the coastline. And this is coming at a time they were referring to the king tides. And the king tides, they happen about 4 times a year. It has to do with the moon phases, the new moon and full moon phases. Actually increases the tides, makes them higher. So that is also going to play a major, major role. But this storm surge, that's where most of the people end up losing their lives, and that's where they really, really get into trouble, is with these storm surges. So we'll see. We'll see what happens here. I'll be covering it very, very closely. I've added a few short videos to the Planet X News YouTube channel, just detailing some of the captures of the hurricane that I've recorded on the GOES 16 satellite. But let's jump into this space weather, because I've noticed something yesterday and today that I've been thinking about this for quite a long time. What creates these coronal holes on the sun? Why do we watch them so carefully? How do they form? Why do they form? Why are they always Earth facing? See, folks, if you look to the back side of the sun, you don't see these coronal holes. You only see them as they rotate around from the eastern limb of the sun to the center Earth facing, and then they start to fade out as they pass by the western limb of the sun, moving around. And I've been watching this now very, very carefully since about 2016. At first, I really didn't think much of it. And then it was back in the later part of 2017 that I started to actually notice, whoa, 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 why are we always having these large, large coronal holes opening up, always Earth facing? And then when I look on the back side of the sun, the atmosphere of the sun is completely closed in, meaning the corona, no coronal holes. Why is that? What's happening? So I have some detailed information here for all of you that's current, and we're going to have a little bit of a learning lesson here so more of you understand what I'm looking at, what you guys that are new to this and you want to start doing your own research, which I recommend, you have a better understanding of what you're looking at. So I'm going to go ahead and get out of this thumbnail real quick. Let's jump out of here. I'm going to shrink my head down just a little bit. I know you guys are probably tired of looking at my big head there. And let's jump into here real quick. I'm going to go ahead and blow this up so the wording is a little bit better here. This is on the spaceweatherlive.com website. I don't use their website all that much, but they did have a pretty good definition of what is a coronal hole. And I'll go ahead and read this for you, and then I'm going to give you a little bit of a better explanation. And it states here, let me go ahead and pull this up here. It says, what is a coronal hole? And it states that when we look at solar imagery from NASA's Solar Dynamic Observatory, the SDO as we refer to it, at a wavelength of 193 or 211 angstroms of extreme ultraviolet light. That's how we're able to see these mechanisms on the sun. Now, we can see the hotter outer layers of the sun's atmosphere. That would be the outer corona of the sun. This outermost layer of the sun is called the corona. The magnetic field of the sun plays an important role in terms of what we see on these images. The bright areas on these images show us hot and dense gas that is captured by the magnetic field of the sun. The dark and, in a way, almost empty looking areas are places where the magnetic field of the sun reaches into space so that these hot gases can escape. Those are the coronal holes, those dark areas. These areas look so dark because there is very little hot material compared to their surroundings. So, if we didn't have these coronal hole openings, now I'm going to go ahead and I'm going to play you a current video that I produced, and it's going to show you the coronal hole openings currently right now. And I've developed a technique that shows you these particles spewing outward from the coronal holes towards Earth. So I'm going to go ahead and pull that up real quick. So we'll jump out of the explanation. And let me go ahead, we'll pull this up. What did I do with it? Don't tell me I deleted it. Oh boy. I think I did. Hold on, folks. I think I accidentally deleted it. Hold on one second. Did I delete it? What did I do? With my video? Huh. Let's pull that up. Well, that just sucks. I just made the damn thing. Losing my mind. Anywho, we'll pull this up. And okay. Yeah, I had this all put together. I had all three versions. I don't know what the hell I did with it. I must have accidentally deleted it. Who the hell knows? But this is the current SDO, and it is in the 211 angstrom of extreme ultraviolet light. This should actually be purple, but I've developed this technique where we can see through the sun's corona, and we can actually start to see all of those. You see all of those little sparkly white dots that are shimmering in the background, and they're all in those dark areas. Well, those dark areas signify the coronal hole openings. They signify the loss of the sun's outer atmosphere that actually block and keep all of these heavily charged particles inside. Now, whenever these coronal holes start to open up, as I mentioned, we don't ever see them on the backside of the sun. We always see them coming around the eastern limb of the sun, and then we're exposed here on Earth to all of these heavily charged particles. So with this technique, we're actually able to see all of those little white speckles. Those are the heavily charged particles that are spewing out from these openings in the sun's atmosphere. Why is that important? Why do we pay attention to it? Well, folks, this is what induces earthquakes. This is what induces problems here on Earth with our atmosphere, our magnetic field, seismic activity, volcanic activity, and yes, our weather. Our weather. Because our ionosphere is so heavily charged right now. All of these particles bombarding the Earth. And on top of that, the interaction with the Earth's north and south pole produces the auroras. And yes, they are, they're pretty. They're nice to look at. They're absolutely spectacular. But that is the interaction with these heavily charged particles hitting the Earth's upper atmosphere. So here is another view, and again, this should be purple, but I've developed this technique where we can see these particles exploding out of the sun and heading directly towards the Earth. And normally it takes a couple of days for these streams to make their way all the way to the Earth in the form of what we refer to as solar wind. Now, I had somebody leave a wise ass comment. Maybe he just didn't know, but this guy said in a comment yesterday, oh wait, what the hell did he say? Oh, if there's no oxygen in space, how can there be wind? Meaning the solar wind. The solar wind is just a terminology. It's just a term. They use the word wind to describe the stream of particles. So yes, we know that there is no oxygen in space. So therefore, there couldn't be an actual wind, like the wind blowing through your hair. So I don't know if his comment was just being, a wise crack or what. But that's what it's referred to. I didn't name it that. That's just a space weather term. So again, here you can see all of those little sparkles of solar wind spewing directly out of the sun. And again, it's all Earth facing. Now, whenever the sun rotates all the way around, and these coronal holes, this will all fill in. As the sun loops around and rotates, that will all fill in again. And it won't be spewing that much solar wind. And I watch this very, very carefully, folks, every single day for years. I watch this. And again, for many years now, I've been watching these coronal holes opening up facing the Earth. But on the back side of the sun, the corona fills in. So this has to do with a magnetic field interaction. So these are interplanetary magnetic field lines that are literally opening up, and they should open and loop back around. And these coronal holes should almost be non-existent or much, much smaller, much, much smaller. But for the, let's see, for about the course of the last 3.5 years, we're almost going on 4 years now, these coronal holes have been almost like the complete size of the sun facing the Earth. So this is definitely one of the main reasons why we've had the increase in volcanic activity and the increase in seismic activity, earthquakes. I know there will be some people that will debate me on that, but you know what? They can say, well, you're wrong, Scott. You're wrong, Scott. But when they say that you're wrong, they don't back it up with anything other than that statement. So if you tell me that I'm wrong, then you have to prove it like I prove all of my material. I show you, and I give you facts, not fiction. So this was one view, and there was one more view. I'll go ahead and pull that up real quick. And this was just a black and white. And again, whenever I reduce this to somewhat of a negative, now you can see even more of these heavily charged particles within the sun's corona as it's all split apart. It's all spewing directly towards the Earth. So now you can see a little bit more. You can see a little bit more of the sun's corona has faded away. And the reason why it is faded away is there is an interaction with another magnetic field that is causing these interplanetary magnetic field lines to just literally reach out into space and just go wherever, just go into infinity. And that leaves these coronal hole openings. And again, one more time, over the course of the last 3.5 years, these coronal holes facing Earth have gotten bigger and bigger and bigger, and just about every single rotation of that star we call the sun, every single rotation when it comes around Earth facing, there are huge coronal holes. Therefore, we are always under the gun of this solar wind, whether it be a mild solar wind or a very intense. Earlier yesterday, I recorded a solar wind spike of about 2.5 million miles per hour. Over the course of this entire year, the velocity of the solar wind has been relatively very, very low. There's been a couple of instances that we've seen the solar wind reach 1.5 to 2.5 million miles per hour, which is kind of normal under those conditions. I do not know why we've had these very, very slow episodes of solar wind. Just haven't figured it out yet. But we're going to go ahead and jump out of here, and we're going to go ahead and we're going to look at a few other things here real quick. And, well, this is just the the normal 211 angstroms of extreme ultraviolet light. This is what we'll normally be looking at. This is what I just showed all of you, but you can see the technique that I use now. You can't see all of those little sparkles of those particles coming off of the sun. This is what you normally see on the SDO. The three other shots that I just showed you, that's my technique, taking this piece of video and doing some abstractions to allow me to see further underneath that corona and really get to see these particles spewing from the sun. So this is what we're normally looking at on the SDO in the 211 angstroms of extreme ultraviolet light. And you could see the big black areas, all of these black areas, everywhere where you see those areas, that is the sun's atmosphere has literally dissolved. It's been completely depleted. So if we didn't have the coronal holes opening up, we wouldn't have the intense fluctuation of the solar wind spewing towards Earth. Therefore, we would probably have very little aurora activity. Earthquake activity would definitely be at a minimum, and the same would apply for volcanic activity. And our weather might be a little bit different. But our upper atmosphere is so heavily charged, folks. I've been watching lightning occurrences across the globe for this entire year. I've never seen lightning like this before. There's a few websites that I go to that detail these lightning strikes. I gotta say, I lived in Miami for 22 years. I've seen some lightning, man, let me tell you. But I've never seen anything like this. And over the last 2.5, 3 years, more people have been killed by lightning in these last couple of years than I've ever seen. It's incredible. So lightning has become a major issue. The increase in lightning is also increasing the chances of major forest fires. And we know we've already seen these effects in Siberia and the Amazon. I mean, the Amazon was a big to-do. I looked at a lot of images, satellite images, as the Amazon was on fire. It's pretty much a natural occurrence. And it seemed like the media overexposed what was happening in the Amazon. And when you view it from space, and I viewed it from a couple of different satellites, it really didn't look all that bad. And a lot of the area that was burning had already been cleared. So I think there might have been a little bit of man-made activity going on down there. But who knows? A lot of that had to do with government. Big government. But let's jump out of here. And I'm going to bring up this CME tracker. And I'm going to begin to show you something that I found very odd. And this is where the interaction with this Planet X object, which would naturally be the largest one. And that's the one that we normally see. And we just had a pretty good capture of it on the 27th of August. Right on time. Remember, folks, I told you the last several days of the month, every month, we will get to see this object. And towards the middle of the month. So sometimes between 2 and 3 times a month, we'll be able to get a visual on this. Well, what does that tell you? That tells you that the Nibiru theory is wrong, is fake, is a myth. We're dealing with an object that is orbiting our planet, or excuse me, orbiting the sun every 28 days. If you don't believe me, then you need to sit down and you need to do about 2 or 3 years worth of data collection and homework, and you'll figure it out. Here's the other thing. How am I able to make all of these observational captures month after month after month after month on the same time? I mean, that has to tell you something, doesn't it? So if I'm consistent and my information that I'm showing all of you is consistent, then what does that tell you? That tells you, plain and simple, that the 28-day orbit is correct. This is what we're faced with. People will say that, oh, that's impossible. I don't know. I don't know where you're getting your information. Where did you study? So, you know, I deal with these jokers all the time with their stupid ass comments. I don't know if they just try to get under my skin, but more or less, people that leave those dumb comments, they're trying to get at you. Okay? They're trying to get at you because they're trying to change your mind on what you're viewing on this YouTube channel. And if you're a member of our private group or our open group on Facebook, and they leave dumbass comments, they're trying to sway your thoughts. I see it all the time, but it doesn't bother me. So anyways, we are looking at the CME tracker. And this, I had to slow it down because on the website, it goes very, very fast. But we had quite a bit of an increase in solar wind, and the KP index rose all the way to a level 6, which is moderately high. But did any of this actually impact the Earth? You would think so, wouldn't you? But when you look very, very closely, you'll see that the Earth was interacting with another magnetic field other than the sun. Yes, sirree. So it's the first of the month, the last couple of days of every month. The Planet X object, the main object, is coming up past the ecliptic, and it's making its way to, this would be coming up on the eastern limb of the sun, and it will start making its way upward, and it will start to arc over, and that will be in about the next 10 days. But as it came up and arced over, it's just about at that point, that's where we start to have the geomagnetic storms, the larger coronal holes, and the influx of electrons. Yeah. So, the electron flux spiked yesterday, started going up the day before. Oh, well, why is that? Well, take a look at the orbit. It's only 28 days. Take a look at the data, and you'll see that all of these things correspond together. I'm not making it up. It's all fact. So whenever we're watching this CME tracker here, now there was no coronal mass ejection. There was a little bit of activity. Now, I'm going to show you something. You see, watch my cursor here. You see the yellow dot right there? That yellow dot signifies Earth. You could see right up here at the top of the screen the color chart. Here's the Earth right here. And then you'll see the date timing up here. Now, as this one wave, you see that one spiral, we'll call it a spoke, like on a wheel. You see that one spoke of solar wind pass by the Earth. And that was, let's get the timing right, on the 27th. Okay. We didn't see much happen on the 27th other than some fluctuations in the Earth's magnetopause, the bow shock. But I want you to take a look. I'm gonna stop this right at, give me a second. Okay, right here. You see where my cursor is. There's a very, very small area right there. That missed the Earth. That missed the Earth. Over here, follow my cursor. See the Earth, the yellow dot? You see the wave here and here. It missed the Earth. Let's take a look at the side view over here. You see these areas right here? It missed the Earth. It missed the Earth completely. But the Earth still responded to another magnetic field other than the sun. What would cause all of the models to go cuckoo, but we didn't get hit with an extreme solar wind? As you can see on the model, the solar wind missed us. It just grazed us just a little bit. I've gone back and started looking at later dates. The end of the month. Remember, I tell you guys all the time, we have to watch at the end of the month and into the beginning of the month. We're going to see some heavy activity in those time frames. And also 10 to 15 days into the beginning of every month. It's all about timing, folks. When you have an object that is orbiting the sun in a very eccentric and elliptical orbit like that, you're going to have periods of time when this object is going to be closest to the sun at the very top. But as it comes down and it goes below the ecliptic, completely out of view, it is further away from the sun and further away from the Earth. Now, people constantly ask me this question: why can't we see it from Earth? Well, folks, I mean, come on. Do you actually think that you're going to look up into the sky and see an object, maybe, bigger than Jupiter, but do you actually think that you're going to see it 90 to 100 million miles away? And it's not like the object gives off its own light. The object is probably very, very dense, very dark in color, probably. How would you see it? Oh, that's right. All of the backyard scientists using their backyard infrared technology. Okay. It's making a joke there. So, the odds of you seeing this from Earth are nil. 0. So let's get back to this. So we know that no solar wind impacted the Earth. We can see it right here. But, once again, at the end of the month, we see the interaction with this object as it passed up through the ecliptic. Its magnetic field interferes with the Earth's. We see this every single month, about the last 5 days of the month, and maybe 1 or 2 days going into the beginning of every month. And again, that coincides with its orbit. And I know you got these jokers out there that tell you, oh, there's no such thing as no 28-day orbit. Oh, okay, I'm sorry. It's on a 3,600-year orbit, like the Nibiru freaks want you to believe. But if it's on a 3,600-year orbit, how in the hell have I been capturing it twice a month for the last 3.5 years? Okay. Tell me another one. You want real Planet X news, folks? You want the real hardcore science? You want the truth? You stick around here. If you want to see mumbo jumbo, go to some other channel. Let them show you lens flares and let them lie to you. Choking on my damn coffee here. My coffee's trying to kill me. Amongst a lot of other people. Get in line. All right, let's jump the hell out of here. So we see that a little bit of solar wind impacted days and days and days and days ago. Basically had almost no effect on the Earth. This actually missed the Earth completely. Let's get out of here. Let's move over to here. Now we get the hell out of the SDO and let's jump over to here. Let's open this bad boy up and let's look at the electron flux. Oh, I've shown you guys this before, right? Well, the electron flux was relatively moderate, no spikes in it whatsoever. Oh, and as the Planet X object now starts to come up right at the end of the month, breaks the ecliptic plane, what do you see on your screen? Bingo. Between the August 31st and September 1st, you see that massive influx of electrons? Bingo. Now, you could see it quickly faded away. That's it. It gets past the GOES satellite, which records this information. So now, the electron flux back to normal. So, let's jump out of here. We'll go back, and let me just blow this up a little bit. We'll get them all on here. So, you can see the X-ray flux, completely normal. We don't have to worry about the X-ray flux because Planet X is not going to induce any spikes in the X-ray flux. So that's completely normal. Here you see this is the KP index right here. August 31st. I know that's kind of small. Actually, I could bring it up here. Here we go. August 31st. Then we started to see right in the middle of yesterday. We saw the KP index spike pretty close to a 6. That would be kind of moderate, above moderate for solar wind. But where was the solar wind? Where was it? It didn't hit Earth. What did? What caused all of these perturbations? What caused all of this? Why is it at the end of the month, every single month? Yeah. That starts to open your eyes a little bit, doesn't it? That starts to open up a lot of questions. Yeah. That's what I thought. Let's get out of here. I'm probably confusing a lot of you. So we see the, here you go. Here's the planetary K index, and you can see right here, the 31st, it starts to go up, up, up. One fluctuation here, and then it spiked halfway through the day yesterday, reaching a KP index of a 6. Naturally, the red color signifies intensity. And it's still going into September 1st, you could see that it's still quite intense, but that will fade away by the latter part of today. Why? Because this object will be completely broken through the ecliptic and already halfway up to about the equator of the sun. And it will be heading back from our view. It will be heading back and around to the back side of the sun. And we won't get any views of it for probably about 10 to 12 days. So I'll be looking very, very carefully around the 10th, 11th, 12th, 13th, 14th, 15th. In that time frame, I'll be looking very, very carefully at all of the instruments, and we may definitely have a small coronal mass ejection somewhere within that time frame. Okay, so these were the ways that I was able to calculate this orbit. These were the ways that I was able to capture this object, because I know the times of the month when this object's going to be the closest to the sun twice a month, on its way up and then on its way back down. That's where we capture it. It's not that hard. It's not that difficult to understand. Once again, folks, for the people that are showing you objects that are in the sky, these photographic anomalies, look, I'm not going to get into the whole lens flare thing, because a whole bunch of people got mad at me and sent me death threats and all kind of weird emails and inbox messages calling me a liar and all these things. Whatever, man. I'm not here to lie to people. I'm here to bring the truth out. And if you can't handle the truth, then you need to not watch my videos, remove yourself from my YouTube channel, remove yourself from my Facebook group and my Facebook pages. Don't ever talk to me again. Don't interact with me or any of my people. Just stay the hell away. Go watch whomever, and they'll fill your head full of lies. And when the shit hits the fan here on our beautiful planet, you won't know what the hell is going on. And you're going to be in some big, big trouble. Yes, sirree. Now, we're going to look at the some geospace models. And I've shown you these before. And here we're looking at the velocity. This is all current. This is right now. As you're laying your head on your pillow listening to me early in the morning, this is what's happening. This is the velocity of the solar wind. And you could see in red, look how red. I mean, this is deep, deep, deep red. Normally doesn't look like that. So as this object literally came up across the elliptical plane, this is what we're seeing. We're seeing a huge influx of let's just call it a magnetic field interaction, because that's exactly what it is. Nothing would affect the Earth's magnetic field other than another magnetic field or an extreme amount of solar wind. And I just showed you guys that the solar wind missed the Earth. It missed it. So what's doing this? Why do we see those constant waves come in like that? Every so often, couple of times a month. Go back, do your research, do your homework, and you'll see that the dates where this object is looping around the sun and it passes by where the Earth is involved, then you'll see all of these spikes. you'll see the contortions on the magnetopause. And then things kind of go back to normal. Oh, well, why is that? So we're under some intense situations right here. I mean, it's not going to destroy anything. And like somebody left a comment the other day that said that I should be killed because I'm constantly lying to people and telling them that the end of the world is coming, and that I've been telling people the end of the world has been coming for years. Folks, you all know me by now. When have I ever said that this is the end of the world? I don't use the word apocalypse. That's the word that Pastor Paul Begley uses every single day. I don't tell you to get good with your Creator all the time. That's what Steve Olson tells all of you. Okay? I give you facts. Plain and simple. I don't think that this is going to be the end of the world. It would take a hell of a lot to destroy this planet. People don't really fathom how large the Earth is. If you were just this little teeny tiny person floating around way out there in space, and you had your own view of the Earth from space, or even from the moon, you would see how large this rocky planet is, and it would take a hell of a lot to destroy it. But we have a lot of situations that are occurring that are making life on this planet somewhat dangerous. Earthquakes, volcanoes, hurricanes, typhoons, cyclones, all of these things have been on an uptick for a couple of years now. And yes, it will get worse. Now, we could get hit by an asteroid. We could get hit by a huge meteor. Yeah, all hell will break loose. It won't be a nice day. But I've never, ever said that this is the end of the world. I've never said that. And it's not. The way I view things, it's not the end of the world. We're living in some pretty exciting times if you like science, earth-space science. And it's a shame that a lot of people are in the dark, per se, because they just, I don't know, they just haven't educated themselves. Yeah, that's all I have to say about that subject. I don't want to insult anybody. This model here shows you the density of this so-called interaction with the solar wind. But we know that there's no solar wind impacting. So you're looking at wave after wave after wave after wave. The darker the blue in those lines going into the magnetopause, and this is a side view. This is a side view of the Earth, and the magnetopause, our bow shock, our barrier. You can see wave after wave, and you can see, according to the color scale right up here, the darker navy blue, more intense, more density, thicker, heavier. And you can see it fluctuates. Now, if that was a steady stream of solar wind, we probably wouldn't see all of the multiple colors. We would see a solid color, wave after wave after wave. What this is showing me is an interaction with a magnetic field other than heavily charged particles. Some people will debate that, but they can debate it and they can tell you or tell me that I'm wrong, but that's all they can say. They could just use those few words and say you're wrong, but they can't back it up. Now, this model shows you the extreme pressure. Now, you're always going to have more extreme pressure on the backside of these models. Right here, you see the red, and you see the little black and white. You see the little black and white Earth. The white signifies the daytime side facing the sun. Naturally, the black is the nighttime side of the sun. You're always going to have more extreme pressure on the back side as plasma forms, as you see right here. It's called the plasma sheath. You're always going to see pretty crazy looking anomalies back behind in this plasma sheath that forms in the magnetosphere. I know a lot of people look at the other ISWA models of the magnetosphere and they see weird things going on with the spaghetti lines, but they really don't know what they're looking at. And with these models, folks, these models, they don't measure things that are going on behind the Earth. They only measure things that are going on in front of the Earth that are impacting the magnetopause. Okay, so you're going to get some distortions and some very, very weird anomalies that occur behind the Earth within that plasma sheath. Okay, so just as food for thought, just ignore what you see going on behind the Earth, because these models really, really can't interpret that. And I know people have shown things on Facebook and YouTube, and they're like, oh my God, look, there's a huge planet behind the Earth. Folks, once again, if there was a huge planet behind the Earth, we would have extreme tidal anomalies. We would have tidal waves that would be hundreds of feet high. Jeez. It is a shame that there is so much disinformation on social media. Everybody wants to be a rock star, but 99.9% of these people don't know their ass from a hole in the ground when it comes to science. It is what it is. So, you can see that the pressure around the Earth during this time has increased. Is it due to the solar wind? No, it is not. And I'm going to show you once again on another model that this solar wind missed the Earth, grazed the Earth. What we're seeing here is a pure, hard, cold interaction with Planet X's magnetic field as it loops around in its 28-day orbit. I've analyzed this for years, month after month after month after month, and it's usually always the same. But we'll get to that right now. Let's check it out. Let's jump out of here. Let's move over to here. Now we'll open this up. And this is the solar wind predictor model on NOAA. And you can see all of these, the plasma density here. Look how everything's pretty much, you see one small spike here, everything's flatlined. You see one small spike here that's going to be coming up on the 1st today. Nothing major. I mean, 600 kilometers per second. Relatively moderate. Now, I have the slider. I have everything stopped because I'm going to do it manually so you can see this. So you see the Earth right here. Oops. You see the Earth right here. You see the sun right there. And this is a side view. This view is looking down on top of the ecliptical plane. So you see the sun right here. You see that this little bit of solar wind. You see it right here. And that is on the 30th of August. Let me move this further out. Look, watch. Now, we're just a few hours into the 31st. What do you see right there? Do you see the entire Earth engulfed in those heavily charged particles, aka the solar wind? No, you do not. You see the majority of that solar wind bypassing the Earth, slightly grazing the Earth. But wait a minute. What time of the month is it? It is the end of the month. What just came up, whoop, through the ecliptical plane at the end of the month? Aha! Our object that we call Planet X. Bingo. Now, all of the things that I just showed you, all of the models that I just showed you, all of that interaction had just about nothing to do with solar wind, heavily charged particles. Nothing. All of the charts and the graphs and the models that we're looking at, well, it proves it. Let's take a look at the velocity right down here. You see this blue area right here? You see the Earth right there. Look very carefully, and you will see, again, it missed the Earth. It missed the Earth completely. So, what caused all of these anomalies? I'm going to show you some extreme things. Just hold your britches on there. So, let's move forward just a little bit more. Let's move a few more hours. Now we are on the 1st. Or actually, we are at 11 p.m. UTC time on the 31st of August, yesterday. Looky here. Looky right there. There's your Earth. There is, you see the little puffy light blue cloud formation here on the model? That was your solar wind. But see, your solar wind missed the Earth. Look down here. Look at the velocity. Look right there. It missed the Earth. But just wait a minute. Just wait a minute. So we could get on, and you can see we're in the 2nd, 3rd, going into the 4th, 5th, and you can see there's another wave of solar wind coming from the coronal holes. And you see how it's a darker green, a little more intense. But this model predicting that it's going to miss the Earth that far out going into the 2nd, 3rd, 4th, 5th, that could possibly change. And again, maybe a little bit of a graze of the Earth, but we'll see what happens. So going all the way back to the very beginning again, you can see that the Earth was just slightly grazed. Slightly. Now, you see that slightly grazing motion? Okay, let's get out of here. Enough of this mumbo jumbo. Let's get into what things really looked like. Let's take a look at the magnetopause. Let me expand this all the way out so it's big enough for anybody to see. Now, I'm going to go ahead, stop this. I'm going to bring it all the way back. Now we're looking at the 31st, 12:33:25 UTC time, a little bit afternoon. We're about 4 hours behind, so this would be about 8 o'clock in the morning on the 31st. You could already see these contortions and compressions in the magnetopause. Well, what caused that? It really wasn't that little mild grazing of the solar wind. I'm going to let this model play for you. You could pay attention to the time, the date, the time and date stamp right up here. It's all current. And you just watch. You just watch and see how the Earth interacted with this other very powerful magnetic field. I'm going to take a sip of my coffee. Now we're moving closer to September 1st, today. So even though our magnetic field is getting a little bit weaker as we go further into a solar minimum, in order to have contortions and compressions like that with our magnetopause, the Earth would have to be pretty well smacked head on with a solar wind. But every month, towards the end of the month, as that object is making its way straight up past the ecliptic, breaking the plane of the ecliptic, we see this happen. And, you know, I mean, 99.9% of just people would say, oh, well, you know, that's an interaction with the solar wind. But we just saw the solar wind graze the Earth, just scoot by. So what happened? Well, what you're looking at is another very powerful magnetic field that probably extends outward in excess of 90 million miles. The Earth's or the Sun's magnetic field, it spews all the way out to the end of the solar system. Jupiter's magnetic field spews out millions and millions and millions and millions of miles from its planetary surface. We don't know much about this object's magnetic field. I wish we did. But based on observational evidence and this 28-day orbit that this object's looping around the sun like this, we see a lot of these compressions at the same interval that this object is looping around. So therefore, yes, it would be affecting the Earth as the Earth is moving around on its plane around the sun, and this object is moving in its orbit around the sun. Yes, there are going to be times every single month on the calendar that we are going to have very, very extreme compressions like you're seeing on this model. And I have to say that on a scale from 1 to 10, 10 being the most extreme, these are getting just a little bit past a 6 or a 7. I've seen a lot worse. And we will, in the very near future, we will see more extreme compressions on our magnetopause, and that's going to be a problem here on Earth. It's definitely going to induce more seismic activity and more volcanic activity, and our weather is going to get a little crazier than it already is. Here's the bad part, folks. We're only a few months into this solar minimum. Solar minimum lasts for about 11 years. As the Earth's magnetic field gets weaker because of the sun's magnetic field during that solar minimum, more interactions like you're seeing right now, more interactions with this Planet X object and its magnetic field, we are going to see extreme compressions of our magnetic field. I don't have a crystal ball, so therefore I can't tell all of you what will happen. It's probably not going to be good, but I don't think that it's going to destroy the Earth. But we are definitely going to see things change on this planet like you've never seen before. But we have to continue. We have to continue to analyze, research, investigate, and increase our knowledge. Remember my saying, I'm getting tired of repeating it. Knowledge is power. It does kind of, get that fear factor out of your mind. The more you know, the better you feel. And let's just face it, I wouldn't want to be one of these people that are in the dark. I would want to know what's happening. That's what I'm here for. Very, very interesting. So let's get out of here. Let's get out of the magnetopause model that we've seen that. And let's get into the solar wind model on the ISWA. I'll blow this bad boy all the way up for you so you can all see it. And you're going to see some spikes over here when you look at the velocity and the speed. You're going to see some spikes over here that are going to exceed pretty close to 2 million, 2.2, 2.5 million miles per hour just temporarily, just for a split second. But we know that the solar wind, the heavily charged particles spewing from those coronal holes, pretty much missed the Earth. So you say, well, how can you tell that? Well, let's take a look at the model. You see this area right here? It's yellow. Look at your scale right down here. Follow my cursor. It should be green, but it's just in the upper levels of yellow. Now, we've seen solar wind hit these models, and you see these bright red bars, boom, 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 smashing off of the front of this model. Where are they? That would signify heavily charged particles, solar wind impacting the magnetopause. Do we see them? There was one light one. That's it. Where did this solar wind go? Yeah, you see, we're at the end of the month. This object came up. It broke the plane of the ecliptic, and it's now moving upward. What's causing all the problems? Was it the solar wind? Nope. You're looking at the Earth interacting with another magnetic field that nobody wants you to know about. Plain and simple. Let's get out of the solar wind model and let's look at the magnetopause model. Okay, you're pretty much going to see the same thing because the detectors record all of this and place it into all of the data. They place it all into these models. Okay, so here's our region right here out in front of the Earth. You can see the bow shock colored in red right there. And you can see our little scale over here. You see one wave. You see that one wave that came through. Very, very light. That was your solar wind. Just a little mild brush with the Earth. But what's causing all of those contortions and compressions in the magnetopause? All of those crazy looking contortions. That would be a solid interaction with another magnetic field other than the sun. Yes, indeed. Interesting, isn't it? Oh, what? You think I'm making this all up? No, I'm not making it up, folks. It is what it is. I study this subject each and every day, every single day. I've been a space buff, oh my God, just about all of my life. And I understand it, I've researched it, and I've studied it extensively. So we can see that no interaction with the solar wind, but the Earth is recognizing another magnetic field. What magnetic field would that be? The moon? No. Mars? No. Mars isn't out in front of us. Venus? No. The sun? No. Oh, did one of my students out there in the live chat say Planet X? Oh, you are correct. You get a star for your forehead. So yeah, folks, we could see that the solar wind was kind of non-existent. So during this time of the month, these last several days of the month, this is what we're going to see. It will be disguised as a solar wind. That may be what some scientists will tell you. That may be what other YouTubers may tell you, but they're wrong. They're just completely wrong. And again, you know, you see people putting up these videos using the ISWA model. Where did they learn all of this from? Probably 90% of it learned it from me. Because I'm the only one that really used this for years to show people the interaction between the sun and the earth and what it's doing to our planet and our magnetosphere, our magnetic field. So let's jump out of here. So we know what the deal is. There's no doubt about that. Now let's jump right over to here. Now I posted a video a couple of days ago, and it was showing this object zipping upward past the sun. That was on the 27th. So, you know, it's not moving like a shooting star or like a meteor, but the object does move very, very quickly in order to make its way around the sun. The sun's diameter is 864 plus thousand miles. So, you know, the sun's pretty damn big. And this object is pretty big also. It seems to be probably, you know, in between 5 to 7 times the size of Jupiter. Now, that's pretty damn big. And because we get different views of it from some of the cameras, like the Soho and the stereo, we kind of get different views of it from time to time. But it's been pretty consistent when I can capture it. When it gets closest to the sun, that's when we see these coronal mass ejections. Because I believe that at its closest point, when it's grazing by the sun, at approximately 500,000 miles, maybe a little further, that would be its closest point on the eastern and western limb of the sun. It is literally pulling plasma off of the sun. There is definitely a magnetic field interaction between the sun and that object. If you want to know more, do some reading about magnetic fields. You can Google it and see what, I mean, I've gone extensively over that subject time and time again. But the sun's magnetic field is very, very powerful. The sun's gravitational field is also very, very powerful. People ask me all the time, oh, Scott, why doesn't this object crash into the sun? Well, that is all based on this object is not stationary. That's the same reason why little Mercury doesn't fall into the sun. In all actuality, Mercury is consistently and constantly falling into the sun during its orbit. But because Mercury and all of the planets in our solar system are in constant motion, they don't fall into the sun. Now, if one of those planets decided to just stop orbiting and sit still in front of the sun would suck it right in. And that would be bye-bye planet. So that's why the sun's gravitational field doesn't pull the Earth into it. Same thing goes with every planet in this solar system. The same applies for any other solar system out there in the galaxies or the universe. As long as those objects are staying in constant motion, they will not be sucked in. However, when you're dealing with two stars that are looping around each other very, very rapidly, and one of them is larger than the other, oh, well, then eventually that larger star will eventually pull the other star directly in, and boom, we have a cataclysm in space. But yeah, that's why Mercury does not get swallowed up by the sun. That is also why this object doesn't get sucked in or crash into the sun like a comet. And comets are much smaller. The sun grabs them and sucks them right in. But we're not talking about a comet here. We're not talking about Hercules. We're talking about a massive core of a star. And again, folks, we don't know the compositional makeup of this object, but I could guarantee you that this object is just like any other core to a star. It's got a massive magnetic field, and we can see those interactions here on Earth a couple of times a month, every month. And that's the reason why the sun doesn't suck it in. Now, this object probably also has a pretty strong gravitational field, and it seems that it's in a constant tug of war with the sun. That may be another reason why we see the sun's outer atmosphere, the corona, being stripped away in the form of those coronal holes. Now, coronal holes have been around way before man. So, what makes this any different? Well, the difference that I've seen is the size of these coronal holes and the consistency of them being Earth-facing. So when you look to the back side of the sun in the extreme ultraviolet views, you don't see coronal holes. You only see them as they are facing the Earth. Does the Earth's magnetic field have that much power that it can strip away the sun's atmosphere? Absolutely not. Something else has to be interacting with the sun, close to the sun, something that has a pretty strong magnetic field of its own, and that would have to be the catalyst for pulling plasma from the sun and exposing the underlying atmosphere of the sun, aka those coronal holes. Let me show you something. So this is what I found scooting past the sun. I dropped a short video on this. I didn't have time to narrate it. Because my schedule right now, folks, is pushing 16 hours a day, 7 days a week. So it's been hard for me to jump on here and do a video every single day. And if I did a video every single day, you guys would probably be so sick and tired of hearing my voice that you would unsubscribe. Anywho, this was the king tides. This had to do with the hurricane. We'll get into that in a second. Let me just back out of here. I think I'm in the wrong area. Okay, here we go. Come on. So this was a little view. I caught this bad boy. I actually have it on video. I'll show it to you. It was scooting by, and you can see it was coming this way, zipping up, right past the sun, right past, and it actually started to create a small CME. I have it on video. I posted that video just a couple of days ago, and this is sad too because I wanted to catch this a little further back into the picture, but because these photos on the coronagraphs are taken in frames every 12, 16, 24 minutes, it all depends. We missed it. We missed catching it, all of it, but we caught the outer part of it. You can see that right there. Right there. And then it was out of the camera's view. But I did catch it on video. We'll take a look at it. And that was these are kind of out of line sequence-wise. But there you go, right where my cursor is. You can see it as it was coming this way. Now, remember, folks, these coronagraphs, some of these are not directly Earth view. Like we have the stereo B, which is off to the left. So some of these views, it's kind of weird. The Earth is rotating around the sun. These satellites are rotating with the Earth. So we get different views of it. And that's where people get confused. Because I've been doing this so long, it doesn't confuse me. I know exactly where this object's going to be on every day of the calendar. If something changes and there comes a period in that 28-day cycle that I don't see this object, well, then something definitely changed. But I think I've been pretty consistent over all of this time, showing you exactly the dates and the times when this object's going to appear. So we have it right there. We caught it on the 27th. And again, it was the end of the month. It was coming up through the ecliptic, making its way, and bingo, there it is on the 27th. Right on time. Oh, this was back in 2014. This was just before Stereo B went out of commission. 3 days later, Stereo B, they took it offline, made up a big story. So let's get out of here. I'll show you that little short video. Where the hell is it? Here it is. You guys check this out. Now this is what I just showed you. I showed you the still photographs. And you'll take a look at the date up above. And you're going to see the object. It's going to come by. Now remember, these are frames. Frames of still photographs. This isn't actual video. They don't put together this information in video form like you guys think. These are still photographs put together to create a video. I didn't create it. The boys in blue created it. Are they deceiving us? No. Does NASA lie? Yes. Oh, I got a funny story for you guys. You're going to laugh your ass off at this one. But you can see I'm not just showing you just still photographs that I photoshopped like some of you assholes say that I do, which I do not. I don't even own Photoshop. But you could see this object coming up. When was it? Right at the end of the month. What happens at the end of the month? This object is coming upward. It's breaking the plane of the ecliptic, and we get a visual shot of it. So let me tell you a little story while you guys are watching this. This happened yesterday. I have this, this one woman on Facebook. She sent me a friend request a couple months ago. She does a little Facebook research on chemtrails. And I guess that she thinks that she knows everything about chemtrails. And she had a post on Facebook yesterday. And it was a picture of the International Space Station with the Earth behind it. And her question was, how in the hell did they get a picture of the space station? Who took the picture? And from what? Well, that's a pretty valid question. Who took the picture of the space station and from what? Well, I answered her question. The picture looked old. It looked many years old. How did NASA ever get a picture of the Black Knight alien satellite looping around the Earth? Did anybody ever hear of the space shuttle? Did anybody ever hear of the Suez rocket that the Russians and the U.S. astronauts use to go back and forth to the space station? Are the astronauts really in the space station? I don't know. We see a lot of deceivery with that. But all I said was, there's a high possibility that that photograph was taken either from the space shuttle or one of the Suez rockets. And her reply to me and she was really rude. I had to ring her bell after that. But she said that was the most indoctrinated NASA fanboy replies that she's ever seen. She called me, a NASA fanboy. I said, listen here, Jezebel. You obviously don't know who the hell I am, do you? And then I had some other crony troll, jumping all over me because I told them the truth. So you see, folks, a lot of people can't handle the truth. Maybe it's because they just want to be right about everything that spews out of their fat mouth or their puny brain. How would you get a picture of the space station? Well, naturally, you would get it from another source. Oh, maybe another one of our Earth satellites? Oh, wow. So that makes me a NASA fanboy. I don't think so, honey. And by the way, I hope you're listening to this, but your investigation into chemtrails, your research that you do, it sucks. Yeah. And then I get these people that constantly say, how can Planet X be orbiting the sun when the Earth is flat? What the? Look, I'm not going to get into the whole flat Earth thing, but just so you know, the Earth is not flat. The sun's not flat. Space isn't flat. Planets aren't flat. You ever notice how everything in your world is round? The moon, stars. Yeah, the earth isn't flat. So that's where we're at, folks. You can see that the 28-day orbit of this object looping around the sun, that's it. It's here, and it's here for the rest of our lifetimes. Let's just put it that way. I don't ever think that things will ever be the same on this planet. We are definitely going through some very, 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 very serious cosmic changes. And, you know, we don't live in this little Goldilocks solar system. Space is vast. There are all kinds of objects zipping by through the galaxy. We're just one little galaxy. And there are billions of galaxies out there. So something can happen at any given time on any given day to our little Goldilocks solar system that we love and behold. And people can't seem to get that through their thick skull. You see asteroids and comets and meteors coming out of nowhere. Oh, well, why can't another planetary object come zipping by? Why? No one's ever answered that question. When I ask, they clam up. End of conversation. Then people say to me, oh, well, what about the Bible? What about the Bible? What about ancient prophecies? What about it? What about wormwood? What about wormwood? Oh, it's in the Bible. I know it's in the Bible, but what does it say? Does it detail anything that corresponds to what I'm showing you? No, it does not. So that's where a lot of misconception, misinformation, disinformation comes from. And I'm going to warn all of you folks, as I've said before, I'm not going to sit here and chop down people, but I'm telling you what right now. I have noticed a massive, massive, massive increase in disinformation all over social media, specifically YouTube and Facebook. People showing all of these pictures of lens flares and camera anomalies and pointing to the sky and saying, look, there's our second sun, there's Nibiru, there's Planet X, and that is all total BS. Now, I stopped commenting to these people. You know, I have people in our Facebook group that show this crap. I even stopped correcting them. Because if they don't have enough time to watch one of my pretty informational live streams, if they did, all they have to do is watch one live stream. And then they would simply see how wrong they are. Where did they learn all of that other crap? They learned all of that other crap from YouTube and from Facebook. Nobody is going to take a camera outside, especially a cell phone camera, and point it up to the sky and take a picture of Planet X or Nibiru or Nemesis or Wormwood or whatever the hell you want to call it. It's just not going to happen. Just not going to happen. So for all of you that do follow Planet X, and I show you the information and I show you the true data, then you should know by now. You should know yourself that all of that hocus pocus that you're seeing on social media is purposely done. Purposely. It's confusing a lot of people. They don't know what to believe. They really don't. And it's sad. And I'm actually tired of correcting people. So if you want the true news, you'll come to Planet X News and you will soak up the knowledge. If you don't, stay away from my channel, stay away from my Facebook pages, and go follow the charlatans. And then you will be constantly in the dark, not knowing anything. You will be following not the truth, but the lies. And if you like people lying to you, well, then you just stay in that motion of following the mistruth. Simple as that. You stick around here, you will learn. You will broaden your mind. You will broaden your vocabulary on this subject. That's a fact. And this is what I pride myself in doing, is helping people understand what's happening. I'm not a fearmonger. I don't induce fear. You want fear? Go to Pastor Paul Begley. He'll induce fear on you. Or you go to some of these other YouTube channels. Or you read some of those UK tabloids online. Oh, Nibiru is going to crash into the earth tomorrow. Whatever. Let's jump out of here. And we're going to end this live stream with what's going on with Hurricane Dorian. And is it in the light? No, it's in the dark. Let me zip over to a clean view of this bad boy. Let me get a couple more views of this. Just let me set this all up for us. And just yesterday, I've been watching the hurricane very, very carefully ever since it started forming, and I had a feeling that this one was going to make its way across the Atlantic, and sure enough, it definitely formed. The area right here, these are the Abaco Islands right here, and this long stretch island right here, that is Freeport, Grand Bahama. That's what I was referring to in the beginning of this live stream. Very, 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 very concerned about these folks. Again, they are only about 20 feet above sea level at one point on the island. At one point. The rest of the island, both on the east and west and north and south sides of the island, man, I'm telling you, they're 5, 6, 7, 8, 9 feet above sea level. Storm surge coming from this monster is going to range between 12 and 15 feet, maybe even higher, which is going to put the entire island, the Abaco Islands of the Bahamas and Freeport, Grand Bahama, completely underwater. Completely underwater. It's going to be devastating. I was kind of appalled by the media not really centering their attention on what's going to happen to those folks in the Bahamas, and they were, pretty much centered on what's going to happen to everybody in the state of Florida. And I thought that was just kind of nasty, because these folks in the Bahamas, they're going to lose everything they own. Their economy, which is based on tourism, is going to be gone in a heartbeat. And that's very sad. The Bahamian people are fantastic. I love them to death. But it's unfortunate that this is going to happen. And this is something that we are going to have to get used to. Bigger, stronger, more powerful storms are going to be the norm. Now, we saw what happened last year during hurricane season. This year has been kind of odd because we haven't seen that many hurricanes. We saw one pretty good disturbance in the beginning of the season in the Gulf of Mexico. I called it weeks before it even happened. I said the hurricane season is going to start in the Gulf of Mexico. Sure enough, it did. I've been watching weather, specifically hurricanes, in the Atlantic for more than 25 years. I lived in Miami for 22 years. I've been through multiple multiple hurricanes. I went through Hurricane Andrew, which was absolutely devastating. And the problem with hurricanes is the closer they get to land, they kind of start a little bit of a wobble. And like with Hurricane Andrew, they predicted that it was going to, come in around the North Miami Beach, Fort Lauderdale area. And at the last hour, it jogged 60 miles to the south and wiped out Homestead. But we were on the top side of the hurricane. And, all of Dade and Broward County was just completely devastated. I lived on the intercoastal at that time, and I wasn't able to get back into my neighborhood for a month. I didn't have electricity for 3 months. No running water, no sewage. So that was a bad time. But we could see this monster rolling through, and it's approaching the Abaco Islands of the Bahamas right now. And by later today, it will be engulfing the entire island of Freeport. And it's going to be devastating, folks. And it's sad. It's very, very sad. But this is the world that we live in now. Okay? You all realize that now. We have many, many threats to our well-being. We have many, many threats to our world, our planet. This is where people need to start waking up. Because when these tragedies hit, they don't know what to do. They don't have the reason why. They're in the dark. They're not awakened. And that's sad. Very sad. But this bad boy is going to be rolling down. And what I was paying very close attention to, I'm going to pan out here. What I was seeing early on with this hurricane, let me get my little drawing tool out here. What I was seeing early on 2 days ago is I was seeing this huge pattern of dry air and these air patterns that were cleaning out the pathway for this storm. And I said to myself, oh boy, with that occurring, that would have driven this storm straight across, right below Lake Okeechobee, when the models were all taking it above Lake Okeechobee. So let's get out of that. So that all changed, but you could still see some of this clearing pattern out in front of this storm. There's a high pressure. There's a high pressure up here. And that high pressure helps to steer these hurricanes. But what I've been noticing is that high pressure it's kind of moving off. And that high pressure is moving off in that direction. When that high pressure lifts, that's going to allow this hurricane to come up and go like that. If that all stays with the same dynamic, the problem is that now hurricane forecasting is harder than it ever was before. Why? Because of all of the changes in the jet stream, in these low pressures, in these high pressures. It was just almost impossible to tell where this hurricane was going to end up. And if all of you were following the news media on the Weather Channel and the Fox News and ABC and CBS and CNN, they were all telling you. They were all saying the same thing. We don't know exactly where it is going to go. The models are telling us this. The models are telling us that. And they don't show you all of the models. They show you just a few of them. And a lot of them were taking the storm directly across the top part of Lake Okeechobee. My biggest fear was it crossed the state of Florida and ended up out here in the Gulf of Mexico where the water temperatures are very, very, very warm. And then you could see the air patterns here. It would have gotten sucked right up through here. That would have been devastating, and it would have been a double landfall. But that's not going to happen as of right now. So the current path for this object that we call Dorian, this big-ass hurricane, pretty powerful, wind speeds up to 150 plus miles an hour already. Will it hit Category 5 before it hits the shore? It may. It just may. But some of the models, most of the models, are now taking it skirting the entire shoreline, and possibly the landfall or the eye of the hurricane just barely making it on land near a community called Oak Island, North Carolina. That's where I pinpointed it. So it's hard to judge because these hurricanes, they start to wobble quite a bit when they get next to land. And with that high pressure lifting off, well, the steering mechanism will now be the actual airflow of what you see coming across. So you can see it right here. If I back off a little bit. Oh, come on, satellite. You could see this airflow right here. If that stays consistent, and that airflow that you see right there, that's going to pull it. Hey, there's an opportunity for this not to even get that close to the United States. But it all depends on that high pressure that's right about there. If that high pressure stays right there and it locks that hurricane into its current path, it's definitely going to make landfall. It could make landfall anywhere between northern Florida all the way up to southern North Carolina, that Oak Island area. Let's just hope it doesn't. I would like to see it just zip on out and say goodbye. But some of the current models don't really show it doing that. We'll take a look at windy.com real quick. I'll show you exactly what I mean. And we'll boost this up to its current millibars. Let me get that in place. Right there. And we will put this into motion. Look at this big cyclone storm out here. Look at that damn thing. Ha! Whew! Out there near the Aleutian Islands, right over top the Aleutian Islands over there in Alaska. That's a monstrous vortex. Could you imagine if that was a hurricane? Yeah. All right, let's get down to this bad boy right here. Let me show you this area of Oak Island, and we'll see if this model still persists in bringing it to that point. Let me back off. I lost it. Is this it right here? Here's the area, Oak Island right here. This is where the other model, the GFS model, actually, I'm going to flip over to the GFS model. This is earlier yesterday. This is where the model was bringing the storm up and actually making landfall right there in that community of Oak Island, North Carolina, but just staying offshore just a little bit. That's not good. That's not even good, folks, because that maintains the strength in the warm water, and you're on the north side of that vortex of the hurricane, the heaviest winds, and pulling all of the water and storm surge. And it could potentially, you see this whole entire area, all the little tributaries, rivers, it would be absolutely inundated. Yeah. It would be pretty bad. But we're going to go ahead and back off here. And we'll see right now. You can see where the Abaco Islands are already starting to feel. It is, what time is it now? It is exactly 6:01 a.m. So you can see they're starting to get the push of water going into the Bahamian Islands there. Freeport is going to be next. And they were talking about this storm slowing down. That is a bad, bad, bad thing because the waters are so warm. 85, 86, 87, 88 degrees in Fahrenheit in these Bahamian waters. Not good. But I'll go ahead and let this play out. Let's see where it takes us, see if it's been updated. You can see the time scale slider here at the bottom. The eye of the hurricane, I'm going to just stop it right there. Let me just back up just a little bit. That is Monday at exactly 11 p.m. Oh, my dear God, at nighttime. Oh, dear God. So you can see that's Monday. Oh, my God. Wow. Wow. That's bad. That's really, really bad. You see the way that the wind flow here is, folks? Let me just bounce out of here just a little bit. You see the way that this wind flow is? That is going to bring all of this storm surge smashing into the north-facing part of the island of Freeport, Grand Bahama. Again, their sea level elevation, very, 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 very low. This whole island will probably be 75 to 90% of it will be underwater. And I mean under considerable amounts of water. Possibly 10 feet, 12 feet, 15 feet. So you just imagine how tall you are. If you're 5'8", 6 foot tall, you're going to be underwater if you were standing flat on your feet on this land. The water would be over your head. So, prayers for the people in the Bahamas. A lot of prayers for these folks. It's going to be a very, very sad day in those islands. That was Monday at about midnight. So let's take a look and see where it takes it. And you see it stalls there for a few minutes. Well, actually for a whole day. It's actually stalling very, very bad in the Atlantic. Oh, God. And if you just take a look at where it's at right now, the worst part of the storm is just about offshore. But here's the problem. You know that the hurricanes they spin counterclockwise. Well, what is that going to do? You see the airflow. That's going to pull all of that water directly onto these shorelines. And you can see devastation. Let me just back it up a little bit. Let's go back down to about right here. Port St. Lucie. So you can see that water inundation around the entire coast. I mean, they're going to get it all the way down to Boca Raton. They're going to feel some of these effects all the way down even into Miami. It will be minor, but they'll still feel the effects. That is actually, down in Miami, it's actually going to push water out, which might be a good thing. But for these folks up here in this corridor, that's going to be pushing all of that water directly inland. Yeah. That's going to be, there's going to be a lot of damage with this. On top of all of that, they're calling for torrential downpours of rain, 12 to 18 inches. So when this hurricane starts to roll through slowly, Well, that rain is just going to keep piling up, piling up, piling up, piling up on top of the storm surge. So we may see a very large portion of the Florida eastern coastline completely underwater and completely destroyed, depending on the winds. And again, folks, there is a very high possibility that this hurricane reaches a Category 5. It's only a few miles per hour off of that number right now. So let's take a look at this and let's see where it goes. And you could see how slow it is. It's lost its momentum, 14, 15 miles an hour, and it's slow. Now it picks up some speed. Now we can see right here, this is Wednesday. Do you see how long this storm is going to impact the east coast of the United States? 1, 2, 3, 4, 5, 6 days, possibly even 7 complete days. So it's going to affect a very, very large swath of the eastern coast of the United States. And you see the size of it. It may actually grow in intensity because of where the eye of the hurricane is situated off the coast, maybe 75 to 100 miles or less off the coast in warm water. In warm water, which we all know gets sucked right up and dumped right back down onto the land. The most powerful forces of this hurricane, it is in a very bad spot. I mean, hell, look, the northern side, this is where the most powerful winds are and the most storm surge just pushing onto the land. And you could see it's going to be affecting all of the coastline of Georgia, all of the coastline of South Carolina, and then watch as it moves up. By now, here, we're seeing the outer banks of North Carolina. Oh my dear God. And these are all inlets. See all that water going to push, all that water is going to push right up in here. All this water is going to push up right inside of here. Here's your eye of the hurricane. Most powerful winds, and bingo. And where do we have that Oak Island? There she be, what I was referring to earlier. And you can see that's possibly where it may make landfall. That's where the model was taking it earlier. This is going to be a very, very serious situation for all of these coastal communities. I would say probably from the coastline, at least 50 to 60 miles inland, they're going to be in serious trouble. But let's back off here a little bit. You could see how the storm has actually expanded from where it was when it was down by the Bahamas. When it was down by the Bahamas, it was about this big. Now that it has moved upward and along the coast into warmer waters and that high pressure has lifted off, the storm has actually expanded. So that is all the way out into Thursday. Thursday. Today's Sunday. That's 5 days away. Today plus 4. So that's Thursday at about 4 a.m. Oh my God. Again, a late night, in the middle of the night, storm surge, nighttime, power outages. This is going to be tragic. This is definitely going to be tragic. Let's go ahead and let's let the model pull it out even more. So, oops, I wanted to see where the eye came in. Okay, so Thursday at about 4 p.m. Yeah, Thursday at 4 p.m., it seems that the eye makes its way. Oh my, this is going to be really, really bad. I mean, this is the GFS model. So if this GFS model stays true to form, you're going to see the eye of the hurricane enter. Oh, Lord. That's North Carolina. It's going to pass right over the Outer Banks. And, oh, my. And, you know, you could guarantee all of this water, very, very warm. This area is going to be devastated up here. Oh, Kitty Hawk. So all this water is going to be pushed in. And all of these little black lines that you see here, these are all rivers. Those are all rivers. On top of that, you're looking at possibly 12 to 18 inches of rain. And if the storm slows down, it's not going to be good. It means more rain will get dumped. Now, you can see this lighter area of green here. You'll see I'm in Pittsburgh, right up here in the corner of Pennsylvania. You could see that Hurricane Dorian is going to be causing all kinds of problems all the way up to the state of New York, all the way across Pennsylvania, Ohio, Kentucky, Tennessee. That's all going to be just one big swath of precipitation. So this hurricane is going to leave its mark. It's going to leave its mark in a very, very, very bad, horrible way. And we will probably remember the name of this hurricane, Dorian. So that's Thursday at approximately 4 p.m. It makes its way up into the Outer Banks of North Carolina along the eastern seaboard. Let's take a look, let the model play out. Now it moves away from the shore. So that is a telltale sign that that high pressure that was holding it down when it was down by the Bahamas has now lifted off and has dissipated or moved out eastward into the Atlantic, because now you see the hurricane is moving much, much faster. When these hurricanes are pushed downward or held down by high pressure, they tend to slow down, and it kind of squeezes the hurricane and it pushes it forward without allowing it to make its natural curvature. And here we're starting to see that curvature, and it's starting to move much, much faster. However, in the position that it's at on Friday at 6 o'clock in the morning, this is Friday at 6 o'clock in the morning. Now you can see the eye of the hurricane is just offshore of Virginia Beach. So once again, you're going to see storm surge in all of these areas as far in as Richmond, Virginia, which you see right here. Here's Richmond. Atlantic City. I mean, you're going to have rip tides, rip currents throughout all of these areas. They're going to take a pretty good beating. The whole entire New Jersey shoreline, you could see the convection, the way it's bringing it in, and it actually looks like it's getting wrapped more tightly, and the eye of the hurricane is not disforming. It is staying consistent. Now, take a broad look at the size of that storm. It's huge. If you took that storm and you transferred it from the Atlantic Ocean and put it inland, it would cover, oh my goodness, probably about 10 states altogether in the East Coast. So that's Friday at about 2 a.m. in the morning. Again, once again, tragic situation when the storms move on land at night, 2 o'clock in the morning. There's going to be a massive amount of storm surge, a massive amount of water. I'm not sure how fast the wind speeds will be, but you know, we're definitely looking at power outages and probably a lot of coastal flooding and heavy downpours of rain. So let's see. That was Friday, 2 a.m. Let's see where it takes off. So now it starts taking off. Oh my. This is not good. Right here. This is Saturday at 1 o'clock in the morning. If the eye of this hurricane stays true, It looks like it's going to make landfall again. Come on, computer. Clark's Harbor, British Columbia. Wow. Nova Scotia. Sorry, not British Columbia. So, I mean, wow. 92 miles an hour. Woo! That shoreline's going to get battered. I think this storm is going to end up doing several $billion worth of damage, not only in the Bahamas, but in the United States, and now making its way up to our brothers and sisters in Canada and Nova Scotia. This is definitely going to be one hell of a storm to watch very, very carefully. And if you're not going to be affected by this storm, man, say a prayer for these folks in the Bahamas and all of the folks that live along the eastern seaboard here in the United States that are going to be affected by this storm. And folks, let me just give you a little warning. You know, if you live in any of these communities, I would say within 50 miles inland, I would be watching very carefully. If you live anywhere near the shorelines in any of these states, Georgia, South Carolina, North Carolina, Virginia, the areas of Maryland, Delaware, Jersey. Look, if they tell you to evacuate, evacuate. Don't play around, because there are still a lot of elements of this storm that we don't know. Remember, these are just models. We're dealing with Mother Nature. We're dealing with a massive hurricane that's going to be producing massive amounts of water, downpours of rain, possibly 10, 12, 15, 18 inches of rain. It all depends on the speed that this storm makes its way up the coast. So that is all the way. By the time it hits Nova Scotia, the banks up there, it's already Saturday at 2 o'clock in the morning. Today is Sunday. So we're talking a complete week, a whole nother week of dealing with Hurricane Dorian. So be on the lookout, folks. I will try to do as many updates as I possibly can for all the folks along the eastern seaboard of the United States. If they tell you to get out and evacuate, gather your belongings, take what you need, batten down the hatches, and move away from the shorelines, because the storm surge is going to be one hell of a doozy with this storm, especially skirting the shoreline. You're going to see those winds curling over and pulling that water straight into the shore. And remember how many high tides you're going to have all along the coast in the course of this upcoming week. Some may get lucky. The majority, they won't. Say a prayer for everybody that will be touched by Hurricane Dorian. It's going to be one hell of a storm riding the east coast of the United States. Anyways, listen, folks, I'm out of here. I know you're probably all tired of listening to me. And keep your eyes and your ears open. And if any of you are on Facebook, you'd like to join our Facebook group, the link's in the description box under the video. All of the links for Planet X News are in the description box under the video. Take care, folks. God bless. Be safe. And if anything critical happens, you'll definitely hear from me. Take care, folks. Be safe.